Howdy there, folks out there in Tops Land. This is the math guy, Mr. Wells, and I'm going to tell you a little bit about average speed and how it relates to our understanding of division. Average speed is calculated by dividing. It is a division problem. What average speed is, well, let's just talk about what average speed would depend on. Um, Average speed. What are some variables that might affect calculation of how fast someone was traveling in a car or by running or whatever? Hopefully, you're thinking that uh, I didn't have this plan ahead of time before I started recording, so I'm just going to write. Um, Hopefully, you think the distance that was covered would be a factor in determining how fast someone was driving or running. And obviously, hopefully, obviously, the other factor, the other variable that would be involved in calculating average speed would be the time that it took to cover that speed. Now, I'm going to uh, get rid of those two words actually, and well, I'll get rid of them in a second. To calculate average speed, you simply take the distance that was traveled and you divide it by the time it took. That's all you do. Distance traveled divided by the time it took. Now that formula is going to make a lot more sense hopefully in a few minutes. Now let's consider this scenario. Suppose you're on a trip in your car, family's going on a trip, and you travel 400 miles in 8 hours. How fast were you going on average? Well, using the formula, 400 miles divided by 8 hours. Pretty simple. 400 divided by 8. Hopefully, 400 divided by 8 is not a problem for you. 40 divided by 8 is 5. So that would mean 400 divided by 8 is 50. Now the question becomes 50 what? Well, it's probably pretty obvious to most of you because I gave you an example that you're all familiar with, the units you're familiar with. 50 miles per hour. Now, watch how I write 50 miles per hour. Notice I didn't write mph because I want to emphasize that that word per, really, what it means is divided by. 100% means 100, oh, sorry, percent means divided by 100. Cent being a root that means 100. There are 100 cents in a dollar. A century has 100 years. Make these connections. So percent means divided by 100. Um, so 100% would be 100 divided by 100. What's 100 divided by 100? 1. So 100% is 1. It would have been better if I had written all that down for you, I'm sure, but 100% really just means 100 divided by 100. 1. 200%. 200 divided by per divided by cent 100. 200%. 200 divided by 100. 2. Okay. I'll get off of the percent thing, but understanding that per means divided by and cent means 100 really makes percents a lot easier. Now, back to average speed. Um, Miles divided by hours give you the units miles per hour. Okay? Now, so 50 miles per hour, notice this is the average speed. That doesn't mean you're traveling 50 miles per hour the whole time. There might have been stoplights. There may have been on the interstate you were traveling 65 or 70 probably. But there were stoplights and areas where were traveling slower than 50, so it averaged out to 50 miles per hour over the whole trip. Okay, speaking of traveling in cars, very fast. We're going to use this formula, average speed equals distance traveled divided by time taken in the context of 24 heures à Le Mans, which translated 24 hours at Le Mans. Le Mans is a city in France that they have this annual auto race. It's actually the oldest current auto race. It's a endurance race, and what they do is basically you race for 24 hours, and it's not the winner is not determined by who finishes first because it's a 24-hour race. The winner is determined by who goes the furthest. So you just race for 24 hours, and whoever goes the furthest wins. Okay, well, let's just say someone at they have to travel. The rule now is that they have to have three people on your team. You can't one person can't drive for 24 hours. It's not allowed. You would probably wreck. You have to have at least three people in your team that are driving for 24 hours. But let's say they made it 3,000 miles in that 24 hours. What would be the average speed of that race for that particular car's team? Well, using the formula, we have 3,000 miles divided by 24 hours. Okay, I'm going to help you work you through a little bit of mental math here. 30, I'm going to write this up here because you should be able to you should think about some of these things sometimes. 30 divided by 24. Well, there's 124 in 30, and then there is 6 left over. So 1, it's a little more than 1, we know that. Well, how much of 24? I'm going to write it the way that you think of it. We got 1 in old school, remainder of 6, which really means 1 and 6 24ths. 6 24ths. 6 is a quarter. So of 24. So that's really 1.25. 30 24ths is 1.25. I could have also gone from the perspective of 30 24ths would reduce to 5/4. And if you have 5 quarters, 5/4, a quarter is a fourth of a dollar, 5 quarters is $1.25. So if 30 divided by 24 is 1.25, then 3,000, which has 2 more zeros, is going to be 125. 100 times more. 125 what? Again, miles per hour. Okay. So, dang, if they travel 3,000 miles in 24 hours, they'd be going 125 miles per hour. Well, the record for Le Mans, the current record is 3,360 miles traveled in 24 hours. Now, obviously that doesn't equal, that's not the same speed because they traveled further. 3,360 miles is further than 3,000 miles. So the simple question I'm asking you, I'm not asking you to find out to tell me what the average speed was. You could find that pretty easily. But is the average speed more or less than 125 miles per hour? Hopefully you see it's obvious that it's more. Because if you travel further in the same amount of time, 24 hours, the time traveled is the same, but you're traveling further than 3,000 miles. So hopefully it's obvious that that would be an average speed that is greater than 125 miles per hour. Now, what the heck? A little mental math again, because it is very easy to figure out without a calculator. That number works out very nicely. 360, I'm going to figure out how much more than 125 it is. 360. 360 divided by 24. Well, let's consider 36 divided by 24. Whatever that is, well, 360 is just 10 times that. 36 divided by 24. How many 24s are in 36? Well, that could reduce to 3 halves. Hopefully you see that. times 10, and 3/2 is 1.5. So 1.5 times 10 equals 15. So 15 miles per hour more than 125, because I was seeing how many more 24s I have in that extra 360. Up here, this says I have 125 24s in 3,000. Well, I've got an extra 360 24s. I'm sorry, an extra 360, which is 15 more 24s. So actually, the average speed there is 140 miles per hour. But my main question was noticing, my main goal here on this page was noticing that if you go further in the same amount of time, you had to be going faster. That should be pretty obvious. Now, let's talk about track and field. This guy, uh, this guy right here, his name is Usain Bolt. He's from Jamaica, and he's the fastest human being on the planet. He is the fastest human being ever, actually. And all these guys in this race had an average speed during the race of about 10 meters per second. Now, 10 meters per second doesn't mean anything to you guys because you're familiar with miles per hour. But meters per second is another valid unit for speed. Now, um, this was the 100-meter race, and Usain Bolt won it. And I won't talk about the time right now, but well, he won it in I think it was 9.61 seconds or something like that in the Olympics. This was the Olympics in London this summer. Um, or I guess I should say the summer of 2012, since this video will be viewable in subsequent years. Um, well, let's take a look at an application of average speed in track and field. Suppose a runner runs a 200-meter dash in 20 seconds. What was his average speed? Well, 200 meters divided by 20 seconds. Well, 200 divided by 20, hopefully that's pretty obviously 10. Now, what do you think the units are going to be? Meters divided by seconds. Meters divided by seconds give you meters per second. That little slash is representative of division, but the slash means per, meters per second, which means every second 10 meters are covered. If every second 10 meters are covered, then in 20 seconds, 200 meters are covered. Now, the world record in the 200-meter dash, guess who holds the world record? That guy right there, Usain Bolt. I think it was the 2009 World Championships in Germany where he set this world record. 19.19 seconds. Now, my question is, was he traveling at an average, was the average speed greater or less than 10 meters per second? Well, if it takes 20 seconds to travel 200 meters, you're traveling 10 meters per second. It only took him 19.19 seconds, not 20. It took him less time to cover the same distance. Hopefully, it's obvious that he had to be traveling faster than 10 meters per second on average to cover the same distance in less time. All right, let's look at another example. 400 meters in 40 seconds would give you the same average speed as 200 meters in 20 seconds. 400 meters divided by 40 seconds would give you 10 meters per second. Now, let's look at the world record in the 400-meter dash. The world record in the 400-meter dash is 43.18 seconds. That record is held by Michael Johnson. It was set way back in 1999. I am not a track and field statistics guru. I did just look this information up before I recorded this video. I knew that Michael Johnson was the record holder, but I didn't know what the record was. I actually watched him break the world record in 1996 at the Olympic trials in Atlanta. And then he broke it again in He broke it again in the 1996 Olympics in Atlanta. I don't remember what those records were. I think 43.32 seconds maybe. But anyway, in 1999 in the World Championships, I don't remember where, um, he lowered the world record to 43.18 seconds, and that record still stands today. Uh, anyway, if it took him 43.18 seconds to travel 400 meters, was his average speed, how does average speed compare to 10 meters per second? It took him longer than 40 seconds to travel the 400 meters. So hopefully you see that the same distance, traveling the same distance, 400 meters, in more time would mean the average speed was slightly less than 10 meters per second. So this is a scenario that you can think about when you're thinking about speed. It helps you think about something real that will help you answer those questions on that assignment that's asking you, well, if you increase in a fraction or a quotient, what effect does increasing or decreasing the numerator or the denominator have? Increasing the numerator versus increasing the denominator, what effect do they have on the speed on the average speed up here? Let me lock this down. If you travel further, if you increase the numerator here, if you travel further in the same amount of time, think about whether you're traveling faster. If you take more time to travel the same distance, think about whether you're traveling faster or slower. That's how you can think about it. And I hope that video helps understand and answer those questions. Well, helps you understand those questions.